I would like to express my deepest gratitude to the Symbol Group for giving me the opportunity to present my research in this memorable year. My supervisor, Professor Ihara, told me about this conference and I applied. I would also like to express my sincere appreciation to Professor Ihara. My name is Kudo. I am with Kyushu University in the Faculty of Design in Japan. Today, my focus will be on symbol for people with intellectual disabilities. I will call it ID from now on. We have been researching the graphic design of easy-to-understand pictograms for people with ID. And comprehension of pictograms for them is virtually unreported. This is because people with ID are not included in ISO's comprehension surveys. In past surveys, we have found that pictograms that are easy to understand for people with ID are equally simple for other subjects who do not have ID. It is also evident that pictograms are challenging for people with ID equally for other subjects without ID. Therefore, we believe that studying the comprehensibility of pictograms for people with ID can contribute to the graphic design of pictograms that are more easily understood by a wider audience. Let me present my contents. I will begin by focusing on the reason for ID and the talents in comprehension survey for graphical symbols. Next, I will pose a question. What is the graphic design of pictograms that is easy to understand for them? I'll finish by drawing a conclusion and mentioning future studies. I would like to mention the background of this study. Pictograms are means of communicating information that involves conveying concepts through images. Their primary feature is that they do not rely on words. However, it is well established that understanding new pictograms that require learning can be challenging for those with dementia or ID. This is a rough historical transition of pictograms. Pictograms are produced explosively in the 1960s. It was later standardized in 1974 to 2000, and it was here that the use of one graphical symbol for one meaning began to take off. However, some subjects spilled over from standardization. These included people with ID, ASD, and dementia. Original pictograms have been created of some of them. Explain the background of having an ID. ID represents 2.5% of the general population. It manifests during the developmental years and is characterized by difficulties in both intellectual and adaptive functioning in conceptual, social, and practical domains. Individuals with ID experience challenges with abstract thinking, reading, and writing. Visual support besides character information are required to understand information. This is visual support depicting a child's daily schedule with ID. You will notice that there is very little text, and instead it is present in picture and illustration. There was a major social trend linked pictogram to ID. This was the adoption of the International Classification of Functioning Disability and Health Framework by the WHO in 2001. This defined display as a social problem, not just a problem of the individual. In other words, environmental factor equal design. Environmental factor equal design also affects the social appreciation and activities of people with disabilities. In this disability model, pictograms are positioned as environmental factors. In response to these trends, special needs schools in Japan have been improving their environments by installing signs, including pictograms, in school to ensure children can view and navigate through them on their own. This is because until then, teachers had to stay with children when they moved from one classroom to another to ensure their safety in school. And there was little opportunity for the children to make decisions and action independently. However, after graduating from high school, children with special needs go out into society. Therefore, the only opportunity to learn independent behavior is during the school years. Pictograms and signs were installed in special needs schools to promote independent behavior and learning for children with disabilities. Another reason is that many disabilities share characteristics with ID. In Japan, students with special needs account for about 90% of the total population. In the US, it is said to be 20 to 30%. The area highlighted in yellow in this figure depicts ID. And physical disabilities such as hearing, vision loss, and infirmity may also be accompanied by ID. Special needs students attend regular schools and classes as well. We have surveyed 355 people with and without ID to determine what kind of pictogram graphic design is easiest to understand. The survey method ranked 7 pictograms in order of ease of understanding. The results are the same regardless of ID. It is evident that pictograms that are easily understood by people with ID are also easily understood by people without ID. While pictograms that are not easily understood by people with ID are not easily understood by people without ID. There are 3 graphic elements that enhance the understanding of the pictograms. 1, person symbolizing the location. 2, motion line, effect line that show movement, emphasis, sound, etc. 3, person taking action. The following 6 conditions, 1, 2, 3, 4, 5, 6 conditions, are necessary for easy to understand pictograms. 1 and 2 frequently view pictograms that are understood with or without ID, so standard pictograms are fine. 3 to 6 are pictograms, 3 to 6 pictograms that are viewed infrequently or that rely on language or symbols that can be improved and better understood by using 3 graphic elements described earlier. The next background is the method of surveying the comprehension of pictograms. The ISO method describes the meaning and addresses the pictogram presented, description of the location used, and meaning of pictogram, and action to take after viewing the pictogram. Questions. In Japan, pictograms for information are standardized in 2001, and that time comprehension surveys were conducted using ISO compliant methods. In the second revision for the 2020 Olympic and Paralympic Games, a paired comparison asking whether this or ISO more appropriate was positioned as a comprehension survey. The figure on the right shows what was actually used. For everyone to experience the discomfort, we actually made a similar one. Here is a description. And description flow by the item name and function. There are certain minor differences. However, the graphic design difference are minor in terms of the three graphic elements we gave to improve the understanding of the pictograms. This is a result. For example, there is no much difference between this and ISO result for the bus stop. Here, this and ISO. This is 55.7% and ISO is 44.3%. However, the result, Japanese subject presented a significant difference. 2 asterisks half. These results are not exactly significant. In addition, these are minutes from 2060 of the results from a survey of people with disabilities on their understanding of pictograms. Let me just run through the main point. There are 3 issues here. I translated on the right. 1, people with disability are asked to work on a questionnaire similar to what was given to the general public. 2, these data were not included in the result for the general population because of the different data collection methods. 3, the sample size of 20 was very small for this survey. Thus, it was treated as a reference. Issues. 1, the survey method may not have considered disability characteristics. Only 20 of 121 could answer. 2, reasons for not including data on disability and therapy planning. The breakdown of the 20 disability is not disclosed. 3, only a comparative evaluation between this and ISO has been performed. This assumes that either this or ISO is easy to understand. Our result with people with and without ID, as well as previous study, reports that many people in these who are difficult to understand. Against these backgrounds, we set 3 objects for this study. 1, comprehension survey methods. Pictograms are one element of a sign. Therefore, we incorporate an element of wayfinding and asked which way they wanted to go. They were also asked to choose one based on their recollection of a situation in which they would use pictograms. 2, subjects not reported. There are no reports of pictogram comprehension, especially for adults with ID. 3, pictograms comprehension and IQ. It has long been a question of whether there is a change in understanding the pictogram depending on IQ. Therefore, the correlation with pictogram comprehension was examined between IQ 21 to 35 and 36 to 50. IQ 21 to 35 is a severe degree of ID. IQ 36 to 50 is a moderate degree of ID. Here is a breakdown of the survey participants. There were 90 people with IDs that participated in the survey. The average age was 34. The IQ was 21 to 50. Disability type was Down syndrome and ASD. 4 of the 19 had simple ID. We use this pictogram of 80 items. These pictograms are used as standard in Japan. Based on our previous research, we also create pictograms for comparative stimuli, which were improved with the addition of graphic elements. Point of graphic change in comparison stimuli, this and comparative stimuli. Person symbolizes location, person. Person and location, person and location, 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 and so on. The survey was conducted in person. This is a visual stimulus for a total of 40 types, reserved left and right, pictograms. Teaching statements were about 60 words in Japanese. Referring to teaching text of the WISC-4 and Tanaka Binet's manual for administering intelligence tests. Here is an example. Emergency call button. You are now on train. You are in the red circle. Beside you, there is a person who has fallen near. Which button do we press to call the station attendant? Here is the survey. The visual distance is 700 millimeter. The size of visual stimulus is height is 180 millimeter and weight is 255 millimeter. The height of the pictograms is 35 millimeter. Data analysis. We performed 2 statistical processes. One was about designing pictograms that are easy to understand. A chi-square test was performed for the control stimuli pictograms. Control is this pictogram and the stimuli for comparison. The results of several people were examined to determine whether there was a significant deviation. The second was about the graphic design and IQ of easily understood pictograms. The graphic design of easy to understand pictogram was examined and compared separately for IQ 21 to 35 and IQ 36 to 50. Result. Here is the main result for designing pictograms that are easy to understand in adults with ID. 11 of 20 items were better understood in comparative stimulus than this. Here are the comparative stimulus and p-value. On the other hand, there were 7 pictograms where there was no difference. No different is B. No different pictograms. And this is easy to understand for prohibition, 2 items. Pictograms and comprehension and IQ. First, let me describe how to read this graph. I would like to focus on the table on the left. The y-axis is percentage for the selected comparative stimulus. The x-axis is percentage for the selected this stimulus. In other words, the upper left graph displays a higher percentage of comparative stimuli selected, and the lower right one presents a higher percentage of this pictogram selected. The group on the left is IQ 21 to 35, and right is IQ 36 to 50 group. Comparing the result of IQ 21 to 35 and 36 to 50 for lineup 2, and please stand on the left and right, found that the pictograms of the comprehension stimulus with the graphic elements of actual orientation and motion line. were selected more frequently in group IQ 21 to 35. Discussion. The primary purpose was comprehension survey method. ID is equal to difficulty in abstract thinking. However, it is possible to implement if the methods are considered. The recall of specific situation also had a positive effect on free listening. Effects were also observed in the free listening sessions. This is what one intellectually disabled adult said during the survey to me. I always see it. It is standard pictograms for information. But it scares me. I would be more inclined to go and ask a question if there was a person drawn. This is a statement indicating that the change in the pictogram design will facilitate the person's activities. This is precisely an example of how pictograms as an environmental factor in the ICF model of disability can contribute to promotion of a person's activity. The second purpose was the comprehension of pictograms by adults with ID. 5 graphic elements were identified that enhance the understanding of pictograms. 1, person symbolizing the location. 2, actual orientation. 3, motion lines, effect lines that show movement, enhances sounds, etc. 4, symbols that represent the location. 5, for arrows, the length of the axis affects comprehension. The longer the axis, the easier it is to understand. However, it was so that the graphic elements might not be well understood under certain conditions easier. For example, one pencil symbolizes a place. Each of comparative stimuli for the caution electricity and station. Station had human area greater than 10% of the pictogram. Human area is this. These were significantly better understood in comparison stimuli than this. Therefore, we can say that graphic conditions were effective. On the other hand, pictogram with 2% of people at the same station resulted in no difference between this and the comparative stimuli. The same was also observed into the actual orientation. It was effective for coin locker and lost and found. Coin locker and lost and found, effective. But it was not effective for lineup too. The difference may lie in the fact that the orientation of objects such as a key and umbrella can be viewed objectively, but the orientation of people cannot be viewed from a bird's eye view because it is self-projected. And some examination of abstraction level of standard pictograms are necessary for the application of motion line. Graphical conditions that enhance comprehension have both effective and ineffective targets. I would like to further clarify this point in the future. The discussion so far has been about the overall result of adult ID, not divided by IQ. This is a discussion of the result of dividing IQ. The actual orientation pictogram is lined up to whether the motion line pictogram is freestand on the right or left. Interestingly, for the IQ, the reversal in understanding that this and comparative stimuli was in person stand on the left or right and line up too. This may indicate that the lower the IQ, the more effective actual orientation and motion lie in understanding pictograms. Interviews suggest that visual experience and memory are related. However, the exact factors are yet to be determined. Here, I would like to mention future directions. The first task for the future is to clarify what the survey failed to reveal. One is to identify the additional condition under which the 5 graphic elements of comprehension are effective. The second is to clarify through future investigation the reason for the reversal of comprehension in this and comparison stimuli according to IQ. However, the broad issue to be addressed is what is needed for pictogram to go from standardized to inclusive. For this purpose, one, we need to develop appropriate comprehension survey method for people with disabilities and establish a method for surveying the comprehension of people with disabilities who are not included in the standard pictogram survey, so that the result can be included in the general result. 2, they can be selected according to the target and the media planning, the scale design of pictograms. Depending on the characteristics of the people and media, pictograms have different graphic designs that are easy to understand. It is now impossible to standardize in a way that corresponds to a single pictogram with a single meaning. Therefore, we would like to draft a scale pictogram design that can be chosen according to the people and media. For now, that is all I have to say. Thank you for your attention.